Good evening. This is a short video for the introduction to the power supply that I designed and built. Um, yeah, this video is kind of like redundant, but today we're going to try to do something a little bit different. Um, okay, the power supply was designed to provide more than 1 voltage, 12 volt and 5 volt. Over here, that in my hand, I have a battery that I found. It was used for a alarm system, and I decided to bring it to the house to test it and also to see whether or not my power supply will be able to charge it. First thing I did, I tested to see if there was any charge left, and it was 0 volts, no charges left. And I said, okay, well, let's see what my power supply can do. So what I did is that before I went to work one morning, I plugged it to the power supply and left it there and charged it all day. And when I got back and I retested, and it was actually still charging. I got 11.7 or 8 volt DC. Okay. Over here is just pretty much a scrap paperwork that where I actually worked everything out. The calculations, so my drawing right here, my waveform and so forth. Calculation for the my peak-to-peak voltage and my LED for the power supply. Um, all right, let's get to the point. All right, this is a 12 volt power supply. It also gives 5 volts. In front here is a plastic glass which I used as the front of the power supply. I've installed my on and off switch and my terminal block, my safety fuse, and this piece of equipment here is a modular that I purchased on eBay a long time ago. This modular consists of a voltmeter, and as you can see, I'm reading 12 volt because I connected to my 12 volt. But another thing I discovered about this modulator, it has its own voltage regulator in it. Because when I press this button right here, little black button, let's see, let's turn this off. Do it again. I get 5 volts. I get 5 volts out of it. Okay, and back here I have my step down transformer, which is a 120 volts to 22 volts. But I only use one side, which is I use 12 volts. I think it's a little more than 12 volts AC coming out of it. I use to supply the AC voltage to my voltage rectifier, which is a full bridge rectifier right here. Okay, and I have 3 voltage regulators. I have two 12 volt voltage regulator and one 6 volt voltage regulator. And I have down here I have my filtering capacitors, my LEDs. The LEDs that I use, the LEDs as an indicator. That's in case something goes wrong. If that goes off, I know something's wrong with the power supply. Here is my cooling fan, and this LED is for this cooling fan. Just pretty much, it's not a bad design, but it just a little something for the course. Right over here is a electronic load unit that I purchased. I purchased it so I can test my the capability of my power supply. What kind of load can I get out of this without it fail, or can it support a certain amount of load? So as you can see, it's already hooked up. When I press this button here, right now I'm reading 12.6 volt, 0 amp. Press this button here at 12.34 fluctuations. I get 0.132 132 amp. So that's just showing you that the load that I'm drawing. Okay, over here on this side, I am using a Tektronix 2246 100 megahertz oscilloscope. Um, I've used it to see my waveform. As you can see on top, I have a straight line that represents my DC, and down here I have my AC waveform. It's just kind of a little bit, noisy over here that you could see all these distortions I'm getting out of this. I'm not too happy about it, but it is what it is. That's what I'm getting out of it. And I have a pick to pick for my pick to pick voltage, positive and negative. Um, Pretty much it for that. Up here is my digital voltmeter. Let's do a simple volt test to see what's going on as far as my voltage concerned. I have 12 volt in this terminal. This terminal here, I have 5.9 volt. So when you round that off, that's pretty much 6 volts. Pretty much that's it for this design. And again, it's not a bad design. It's I look forward in the future to do a little bit more, much better, a bigger power supply. That's it. Any questions?